using AI for educational purposes. So I was taking a Dr. Centron's class in the fall, and I had the opportunity to actually get hands-on with the coding and creation of AI. And now as an educator, I've had some experience using AI as a tool in my classroom.
Great. Now, Bob, it's your turn.
Good morning, everyone. My name's Bob Price. I'm a professor in the Department of Mathematics and Statistics here at ETSU. I teach a intro stat course, Math 1530 is the name, and I also teach a graduate level course in statistics. That's my background is statistics. And I've been playing around with ChatGPT, Copilot, some of these AI for me. So it's very helpful in coding in R, which I use R in stats, or even Python. But also I've used it for, we're playing around with creating multiple choice questions for Math 1530. And then I've used it in my intro stat course just to show them at times that it doesn't always give you the correct answer, just to make sure that they're aware of that. It's not perfect, but it seems to be improving. And I just play with it. As we get to the breakout, I just have a conversation with AI. It's kind of funny at times, but I'm learning a lot about it. Thank you.
Great. So I'm gonna share my screen. I'm gonna do an overview for about 10 minutes or so, and then I'll switch to Gemini, which is a tool from Google. So yeah, let me do that. So let me take over and share I have two desktops. So if you see me switching my face there, is because I have one desktop that's on my left-hand side. So I'm not trying to ignore you or anything like that. Okay. So let's see what that looks like. A little overview of what we discussed in part one, but if you were here, as I said, you were here, maybe you forgot about it, totally fine. Artificial intelligence, there is not exactly a universal definition. There are you find several definitions, they have a lot of things in common. So I'm going to give you one definition that I like to use. And I would say artificial intelligence is a sophisticated form of automation. Um, the sophistication comes from the ability of having a computer take input data for making predictions or making decisions with that input data. And so it's that process of ingestion of data, if you will, that this is where the computer learns. The word learning would be analogous to what in applied mathematics or in statistics we would say estimation, when you can fit statistical formulas, mathematical formulas, you can feed that to some data and then estimate parameters. You would then use the parameters to try to better, make forecasts or predictions with that artifact, with that formula. So that idea of estimation is what translated in this language about learning. When those computers have the ability to learn, then that's what brings the autonomy. That's how they can make decisions based on the data they receive as an input. And that's different from having computers programmed with rules. With a very long list of rules and scenarios, the computers may also make decisions, but that would be another type. That's not considered autonomous systems or learning or intelligent in the sense of artificial intelligence. So a very specific branch of AI, a subdomain, is one in which computers would create things, would generate, would make output. And so this generation of output is based on commands, based on instructions, commonly called prompts. And that's what the human operating the AI would input these commands, and then the AI would use all its machinery to produce that output compliant with those specifications. So what you're seeing on the screen is a very nice representation of a scenario in which the commands, the so-called prompts, come. This looks like a conversation. This is the type of conversation we would have in our smartphone by text. A conversation. This is having a conversation with a chatbot. And so usually this is used for creating output that is in the form of text. So another way of using generative AI is to create the output to be images instead of text. And so you can specify the prompts in usually with language. You could also specify the prompts from voice to text. But for now, for illustration purposes, let's say that we pass a sentence or a paragraph with the instructions, with the prompt, and then the AI would produce some image. Now, one of the applications of generative AI is very efficient for, is definitely using natural language. And so if you want to translate between one language and another, say English language and German, or say between Spanish language and, I don't know, French, that type of interplay, that type of translation is something that these generative AI systems can do very well. But it can also translate between a natural language and a programming language. For example, from English to C++, from English to Python. And if you have some code in a programming language, like for example in C++ and you want it in R, so that's another task that is well suited for generative AI systems. So in this context, excuse me 1 minute. So in this context, part of what's involved here is data that is not the usual data that when we learn statistics, we learn a lot of statistics based on data that has the shape of a table. So a lot of the data files come from Excel or they have the format CSV. So we're using the Google Sheets or Excel or something like that. And that's very well suited for data that has the shape of a table or tabular data. Now, what we're facing with these technologies at this point in the 21st century is that also the tabular data has very good structure because it has the structure of rows and columns. So what we're facing with these very modern technologies is another domain of data that has in its raw form, the data has no structure. It's called unstructured. This would be that, for example, text data is considered unstructured. Image data and audio data, that would be part of that domain of unstructured data. So there is a requirement or tasks of pre-processing that data and kind of start using before it can be passed on as input to some of these systems. The data has to go from unstructured natural form into some kind of tabular form, some kind of a structured form. So for text data, this probably dates back to the roots of a branch of computer science called natural language processing. So 20, 30, 50 years ago, natural language processing had little to do with what we consider today machine learning or AI, artificial intelligence. But today, there is an explosion of a lot of these automated tools. And so the field of natural language processing and natural language understanding, they are evolving very fast. And in those domains, there are these so-called models, which would be things we would use for text data analysis. These so-called models called language models, but because of the volume that how they are evolving, they're called large language models. So what is represented here are some of the names of these models: BERT, GPT. I'm sure you have heard of ChatGPT. So ChatGPT is based on GPT, Flant, T5, Llama, Palm, Bloom, and part of what's represented here, it's not an accident. The size of these circles has to do with the capacity of those models to handle a number of parameters. Okay, so I'll tell you a little more about that capacity in just a minute, but just to also give some illustration. So LLMs, short for large language models. There are a few illustrations of use cases here. If you want to use generative AI by means of large language model, to write an essay and write a letter and write a paper and maybe write a book, that definitely is a task that this is well suited for. If you want to, instead of writing, you just want to create a summary, maybe you have a document that has 1,000 pages and you need some kind of summary in 3 or 4 pages, something more digestible. This can do that. Translation between maybe you have 1,000 pages of something that's in English and you want that translated into Spanish or German. Not a problem. This can do that. And then there is information retrieval. It's kind of like extracting information, similar to summaries, creating summaries, but maybe a little more targeted. And so you probably have heard there is in computer science, there are technologies called APIs that are basically the agents or channels that would allow systems to communicate with each other and to transfer information very efficiently. So we're going to see today some demos where we're basically copying and pasting into a box that when you're using API are for tasks that you can do at a larger scale and it's more efficient kind of uploading files, really like in a more automated fashion. So here's an illustration just to gain some sense of the capacity or the ability of large language models. So there's one called BERT, and BERT may handle somewhere around 100 million parameters. Let me repeat this. So 100 million parameters. What is a parameter? Okay, let's just, to motivate here, I'm going to type in the chat something like y equals 1x plus 5. So if I type that, y is a function of x. That's the equation of a line where x is the independent variable. In general form, we would type y equals mx plus b. So in that form, y equals mx plus b, m is a parameter, b is a parameter. So that would be an example of a model that has 2 parameters. We're saying that BERT, little BERT here, may handle 100 million, 110 million parameters. And then Bloom is a monster. Bloom is a large language model that can handle 176 billion parameters. So this is mind-blowing, at least it is for me, how with one type of large language model, you can have an order of magnitude of 10 to the 6 in terms of the number of parameters. And with Bloom, with another type of LLM, you may have an order of magnitude of 10 to the 9 in terms of the number of parameters they may handle, right? So this is part of what's happening right now. So the one of the things that has made this very possible, this ChatGPT is so accessible, is that when you test it, it runs and you see it and it works. So you give the prompt, it produces something, and then you see the output. And so we're looking at fractions of minutes, I mean seconds really, sometimes fractions of a second for this computer to produce what we are asking. We're not waiting minutes, we're not waiting hours for sure. So how is this possible? It's possible with something called computer architecture, which has this name transformers. So that acronym GPT, G stands for generative, P stands for pre-train, and T stands for transformers. So language model, that's what's summarized here. Understanding language is a little tricky. It's a little challenging. For example, consider the sentence. So the teacher taught the student with the book. So from a sentence like that, one may wonder, well, there is mention of a book there, but is that a book that belongs to the teacher or is that a book that belongs to the student? So humans are remarkably efficient. Humans are very good at reading sentences or paragraphs, reading language and interpreting the context of like, well, this word is referring to so and so. But when you are talking about programming a computer to perform this kind of function, to infer, what is the context, this is where algorithms and efficient architectures, they can make the difference. So transformers were something invented around 2017. This is kind of a snapshot of the article where they were first surfaced. Transformers are very efficient at scaling. So the reason why we see these language models with millions and billions of parameters is because now you could handle that with neural networks. That's another just another technical term. And you can also handle that with transformers. So being able to do calculations or computations simultaneously, that's also called parallel computation. That's one thing that distinguishes transformers and make them produce outputs extremely, I mean, we're talking super, super fast. So yeah, okay. So I have maybe a minute or two to debrief you. We will um, today we will unpack more details about uses and abuses that of artificial intelligence, and that's part of another domain, super, super active right now, very important, I think, that is called responsible artificial intelligence. You may argue that that responsible may also be branded or rebranded as responsible statistics. And then in the context of responsible AI, but specifically responsible generative AI, there are three main highlights. One that has to do with toxicity, another one that has to do with hallucinations, and then intellectual property. So I want to tell you a couple of things. Large language models, and that being part of generative AI, they may actually, yeah, they could be very good at creating what you are asking them on command to create. But in that process, they may also create, potentially harmful and like whether it's text or images, there could be some content there that it's inappropriate. So just as this is automated, an automated form of some kind of systematic way of operating, there could be also mitigation policies or strategies that can be put in place. Curating the training data. So for machine learning and AI systems, there is a framework of using part of data, a portion of data for training, and then another portion for calculating evaluations of performance of the models. So it's one part of the mitigation strategy here is to, train some guardrail models to filter out some content that is deemed like this should not be part, and the diversity in the group of human annotators. So it's not all, you may think of this as having some kind of hybrid setup. So there are parts that need to be tuned by hand, basically by humans. As far as hallucinations, I just want to mention this because just like with humans, you may think like people that maybe use drugs like mushrooms or LSD or acid or something like that, and then they start seeing things that they're just tripping, things, seeing and hearing things that are not really there. So computers in large language models, they may have similar. That's why it's called hallucination. So this would be a scenario where the output is basically trash, is basically output that is garbage, but is like nonsense. But is if it were directly nonsense, would be very easy to red flag. But this has the large language model has the ability to disguise the nonsense, and at first glance, it sounds good, it looks good. It requires a little bit of like you as a human, you really need to come there, very like examine it from different angles and realize like this is nonsense. It sounds it's camouflage here, but it's nonsense. This is the computer having hallucinations. And so that could be very damaging. Imagine if you're using this for creating summaries or retrieving information out of documents that are thousands and thousands of pages, and if you're not aware that the computers can commit errors, okay, and so the summaries may be compromised, okay. And then there is also that part about intellectual property. So when you're using these systems, um, who is creating these outputs? So are you writing a document and then getting a draft or talking points or initial outline out of the computer? Or would you provide that outline and then you get like another, so is this like a interplay of templates and you're polishing and editing the templates and you produce the final version? Or, there are new, this is still under development. And yes, just one more thing to be aware of. Okay, so I think now I need to get out of the full view here and I can switch into the demo. Okay, just give me 1 second. Okay, so this is what we're gonna do now. I'm going to demo for you a system that's called Gemini. It's a system created by Google. And I'm going to go, what you're seeing here, I'm just going to do the demo. If you can just look at what's going on the screen. And then after this demo, we're going to go into breakout rooms and you're going to be able to dive in a little deeper. Okay. So, so this is what we'll do. I'm going to enter. So it says here in the lower part, maybe I can use the annotation. And then I'll tell you. So one of the breakout rooms is actually with me. In my breakout room, we can explore this a little deeper. And, but what I want to do right now is for everybody to see on the screen. Perhaps you have done this before, but if you haven't, that's my point. I want to set a baseline, do a demo for you, and then in the breakout rooms, you'll have the ability to actually do this yourself or something very similar to this. Okay, so here, I first, how do you use Gemini? With a Gmail account, with an account for Google Drive, you would be able to use this tool. I'm already logged in here. Um, so I'm gonna go there to that lower part. I'm gonna start entering things of my choice. Okay, so for example, these are the kind of things I want to enter. I am interested on, what did I say here? Yeah, okay. Yeah, I'm interested in this. So I am teaching a class that's called trigonometry. And in that class, there are mathematical functions called sine and cosine. So what I'm typing here as a prompt, as a set of instructions, is provide the definitions for, and I have several words there, but I first say, given sine and cosine functions, provide the definitions for amplitude, period, phase shift, and midline. So I run that prompt. This takes a few seconds. It comes back with, this is a conversational chatbot. Oh yeah, sure, absolutely. Here's what you were asking for. Amplitude. The amplitude refers to this. Period. The period is the horizontal distance. Phase shift, da da da, midline, da da da. Okay, so I asked for definitions, I got definitions. How was this happening? What happened there was that the AI was surfacing. I guess we used to say surfing the web. Remember, maybe some of you are too young to remember this, but in 1995, I remember Netscape, and then there was a notion of surfing the web. So this large language model was surfing the web. It was almost like Surfing USA by the Beach Boys, surfing the web and Wikipedia and everything. That's what they are, very efficient, finding information in a lot of the information that's posted in public websites. So now I'm going to move this into a slightly different variation. So I want to still involve the definitions of period and midline and all that stuff based on the context of sine and cosine functions. But I'm going now to ask the AI to create a game. Okay, this game would be the type of like worksheet I would be able to use in a classroom with my students. Okay, this is what is coming back. The goal is to become master of sinusoids, I guess sinusoidal functions. So it tells me the materials, how many players are needed, the rules of the game, There is even some kind of bonus. There are variations. It create this. This would be a way of creating a worksheet for something I could do. Oh, okay. So I hear Kambela. So the sound not great. Is that okay? So yeah, we don't. Kambela, do you mind maybe logging out and then logging back in? Sometimes that helps with the resetting. But so let me do one more demo. So that was creating a game. I'm going to ask, this is something similar. I'm going to ask for, I could say quiz, but I'm going to enter here, create a formative assessment, okay, with the definitions of, and I already have the definitions kind of in memory there. Yeah, when you see this little symbol kind of rotating and stuff, it's so instructions. That is part one. This is matching questions. Part two, identifying graph interpretation. Part three, it is bonus. Now, this is an assessment, little quiz or something. And then when it created that assessment, I do have an option here that says show drafts. And when I look at that option, there is draft one, draft. So these drafts are like variations. So if I go to draft three, there are like variations of that assessment, right? So I want to do something. I want to do the following. Okay, so I'm going to say, um, I want to say this. Okay, create graphs. Okay, create graphs of sine and cosine. I want to see if this actually displays exactly as it did when I was trying this before. It did. So I have a graph there, but the graph is also interactive. I can hover the mouse over one curve. So the blue line is cosine, the blue curve is cosine, the orange one is sine. And this is interesting that it's interactive, but also show the graphs, show the code behind this result. So this, to produce this graph, the machinery was using programming, and I'm gonna copy this. This is written in a programming language called Python. So I'm gonna say here, convert. Okay. So convert from Python to R. R is another language. And I type all that code and then hit submit. And yeah, it is going through it. So the output is telling me, okay, here's the R code equivalent to whatever you enter there. There is all that stuff with R. But then, very importantly, below, because this is doing a translation between one programming language and another, it's telling me, hey, and there are some explanations here. So ggplot is a library in R, this command, so it's kind of giving me, this is how you would do it in one language, this is how you would do it in the other language. Give me those guidelines, and this could be, I think, quite useful, especially if you are more familiar with one language than another. Okay, so yeah, I think this is good for the demo, and we can then switch over the breakout rooms. Are there any questions? Okay. So Mike, I see Mike Garrett. Are there any questions so far or comments?
I have concerns because I teach this R class, and I'm concerned about like no matter what you do, they will find all the answers online. So how do we test them then?
That's a good point, and I wanna chime in more about that, but not right now. But I really like this, we. I think my short right now for now to go into the breakout rooms is we as educators. I think we first need to understand these technologies, but we also need to start brainstorming about like where this is not the same game. This is not the same landscape, not the same
Yeah.
challenges, right? So like I used to be able to assess in a certain way. Well, we're gonna have to change that because, as you point out, now there is like a smart tutor, a smart chatbot that is doing what we used to call the homework for them, or the exam, or write the code for them. So yeah, let me circle back. But so for
Is
now,
this going to be answer? I'm sorry, is this going to be answer this question I have? Will you be answering in the break rooms or it will be like common for all of us?
Uh, we come back to circle on this after the breakout rooms
Okay.
because um, Mike Garrett also has found is going to debrief us a little bit about um, part of what you have to do is that you have to set policies and guidelines and parameters in your own classroom about, okay, so maybe one policy is do not use AI. This is for maybe that's one policy. Another policy is use it all, use it as much as you can. So like the two extremes, super embracing, hugging the AI there. And then the other one is like anti-AI, completely fundamentalist. And maybe there are policies in between. But then what one of the things we have after breakout rooms is to there is a report with some guidelines, and it doesn't tell you what to do, but it gives you some ideas, and we will go over where this report is posted and have some debrief, and then there we can open up and maybe brainstorm because we need help. I think, we need
Yes,
we
I'd
need
like to.
help brainstorming at first and see everybody has to find what works best for their classroom and their student population. But we definitely need to these forums are quite important. Okay, so we are going to, I'm going to open the breakout rooms. There are three. Let me check the
Right.
settings that I have. Yeah, hold on, Mike, 1 second. So the breakout rooms are supposed to allow participants to choose and they can return to the main. So we're going to have three plus the main room. And okay, Mike, go ahead.
I was going to say what I'm going to focus in on, because a bunch of people asked for it in the last session, is AI assisted tutoring sessions. What do
Yeah.
those look like? There's a couple of examples out there. And it's interesting, Ariel, when I got two transcripts I'm going to walk folks through and then let them play. But in each of them, one of them was toxic and the other one had hallucinations. So we can kind of see what those look like in these transcripts.
Okay, so the breakout rooms, when I open them, you're gonna see where Mike is gonna be in room number 3. This says room 3 Flexi. Flexi is the name of that smart tutor. And room 2 is school AI. So Andrew is gonna be in room 2. And then room 1 is ChatGPT. That's where Bob Price is gonna be doing a demo about using ChatGPT to create question banks, or I don't know, maybe some other things. All right, so we'll have 30 minutes. Pretty sure you have the ability to come back to the main room. I'm gonna be in the main room, and then we'll resume. Okay,
Ariel, which one am I in again?
three,
Three.
number
Number three.
3. It says, I think you're gonna see room 3 Flexi.
Okay, thank you.
Okay, so yeah, this is for 30 minutes. Okay, here we go. Okay, so I think I can in this room I can explore a little bit more Gemini with you, but I want to show you something because the other thing I like to do with you here in the main room is to also show you how you can find tools like this. So first, you're seeing my screen right now. This is kind of using. I meant to do this to share documents, and I understand that. Let me put this URL here. I understand that sometimes this isn't display, so I'm going to show you something. In this GitHub repo, there is a PDF that says curated GAI tools. So if you are able to go exactly to the screen where I am right now, of course, you can just, I can just type this exact URL of this. And you, in this part, you want to choose the option to download. How do you do that? So here, here on this right side corner, there is a like an arrow pointing down. And that's where you can download this PDF. That's what the best thing you could do, download it. And possibly the other way I have to share this with you is maybe in the chat. Oh, yeah, but it doesn't. I cannot do an upload in the chat window of, yeah. Um, so once you download this PDF, this is what this PDF would look like right here. And then one of the things that's in this PDF is this product index. Okay, so I'm gonna copy that link. Copy that link here. And of course, I can just very simply, maybe this was a convoluted way of reaching this, but I can simply put that URL of index.edsearch.com over here. Okay, so I don't know if you had used this before. I have used it for finding other tools. EdSearch is like a magazine, so this is not exactly a search, it's trying to sell you something. This is part of why I like and I want to, you can also filter products, but I want to show you something, perhaps product category. Yeah, this is one way. Okay, so I want to be able to pull some tools that maybe can be used for this tutoring and maybe assessment, instructional support. Maybe this, let me choose that, and learning technology, special needs, talent. Yeah, let's go maybe with that, those. And you can also filter by discipline, features. I'm trying to see if there are features of AI, learning interaction. So I'm gonna filter by math, cut by area, content area. Algebra. Okay, maybe this would filter a few. Okay, and this is still giving me too many options there. Features, interactions, text specifications. Yeah. So I just want to pull one of these and see what it looks like in terms of the actual profile. So I had not review, but these are like index cards for products. So this type of card has some metadata about what this product, the main features, but sometimes it also has, and this is what is internal to EdSearch or specific to EdSearch. They have their own system of validating compliance. For example, I'm going to choose this one about privacy. So EdSearch would have ways of validating certain parameters of data privacy, and that would be stated usually here. And so this, without getting into too specific about what this tool is it good or bad? That's not exactly, this is not going to have reviews, but this may have this type of information or metadata in terms of interoperability, privacy. Sometimes, excuse me. So this would have information sometimes that's a little more extended in terms of digital pedagogy, research and evidence, that kind of thing. Okay. So of course, it takes it takes some practice here, finding out exactly how you're filtering. This is how I found Flexi, and this is how I found School AI. Maybe I can type that here. School AI. Yeah, now that I think about it, maybe I can just type AI, period. So yeah. Oh, there it is. School AI is one of the things that in one of the breakout rooms they're exploring. This is a platform that's already integrated with large language models and things of this sort. And so it has a little debrief there, intended use, software requirements, and it links. Sometimes the product website is a little off. Yeah, Karen saying so many products. It requires practice on your end to be aware of how you're filtering, right? So but I like this validation. For example, this one also has about privacy. And when you're thinking about using some of these tools now integrated into your classroom, where your students are actually, you have ability of monitoring, creating accounts, and then from your end, you can monitor their progress and monitor their work. You, the, you and your students are creating data lakes, lakes of data, like so much data, so and this is part of what sometimes it takes us a little bit of time to gain that awareness. So this setup about how the data privacy, because if you're in, like many of you are in K-12, then your students are not adults, so there are even more layers of uh, protecting the data of those individuals. And so I think this is, I don't know, the risk of using some of the free tools, Google Drive, or to some extent Microsoft 365, that they're not free, but the risk is that sometimes it's too open, that setup, right? So using one of these systems or adopting one of these systems also requires having a little bit of understanding or planning about things that have to do with data privacy and data management. In yeah, okay. So let's see. Um,
It's pretty overwhelming.
yeah, it is the product index a little overwhelming, but even maybe I can go back to this Gemini. And one of the things that you're supposed to be doing with Gemini is also creating images. So I'm gonna maybe, but um, yeah, so there's something called DALI, and there are some generative AI tools that are specific for visual and image generation. That is when you create, okay, but how do you do this? That maybe it's a point to start if you wanted to explore this together with me. So Gemini, Google. You go to this page, and this is what the page would look like, and then you would have to sign in. And so usually you sign in with one of your Google accounts. I have a few. So that example, see that image over there of that car? That looks, I don't know, to me it looks kind of funny, but that's the kind of image that it would be possible to generate. So once you're logged in, yeah, so here, I don't know, let's say create a cartoon. I was successful in generating some images before. Okay, so it seems that now it's going to create something. But this morning I was asking for specific images. Yeah, and this is the message I was getting, that basically it's telling me no. But it's interesting when it says, like, it hits a wall, like I cannot do that. So it would, okay, so Copilot. Okay, so Copilot. So yeah, what kind of malls? When you say malls here, maybe Mahua Chakraborty. Maybe you can tell us a little more either in the chat or the microphone. When you say malls, what okay. Um okay. Well, this is a start. At least
That
this
is a
is
hallucination.
I think it yeah, look at that. So
That's awesome.
is this hallucination? Maybe. I mean, you can see a real, something looks real over there in the second on the top. And
But it's like you can see the metaphors, like, like
yeah,
a pool ball and a golf ball and
yeah. And then there are things here like circulating around, like I guess. But Mahua, this it sounds like that context that what you're looking for, these chemistry models. It sounds that that would be very doable. So I think it's more of a matter of um, finding the right prompts or some good
Right.
prompts.
And yeah, and also the atomic structure of different elements, if that's something, rather than creating it manually, which they used to do in the past, they can definitely use this tool to create one, correct?
Yeah. So what would be one element that we can say here? Like hydrogen, maybe? Like
Yeah, hydrogen has only one, so you can take something different like beryllium or lithium or something like that, which has more than one electron.
right. So I should
Yeah,
say,
lithium will be fine.
yeah, but I should say atomic model for lithium.
Yeah.
I'm so curious. Let's see what. I'm also terrified that you pass a
That's
prompt, and
that's
what if,
exciting to see this in a 3D mode. Yes.
what if you pass a prompt and what you get as the output is something completely inappropriate? Like an image is like, oh no, like so
Yeah.
but I don't know how real this, so change image. Okay, when you go to change image, um I think it maybe generates or generates variations, and then you could um and this comes back with some text there. This is really cool. So maybe you guys don't know, but Karen and Koda are people that they're joining this session today because I know them. I invited them, and they're so kind. Koda is like in Pacific time mode. So, but Karen is a synthetic biologist. So, and she's
I'm not.
also a
I'm a
graphical
designer.
designer, and she's a lot of things. So, Karen, what of you can think of, what could be a prompt here of something based on synthetic biology that we could demo for?
Um, I mean, how about the metabolic pathway for beta carotene?
For what do you say? Beta?
Beta carotene, yeah, carotene with a C.
I'm missing something here. Is that right spell?
Uh,
I think it's CA, right?
Yeah.
But two words, let's see, maybe, I don't think. Oh, I forgot to say, let's see.
Ooh.
What is that? Here,
Just
this looks
it's a
like a,
carrot. It looks like a weird carrot sweet potato thing.
I was gonna say the cake.
That's a
So
hallucination.
yeah.
That's a cool
Okay.
way though of
And is this also, I don't know what that is.
that's cool. So how did you get it to just generate the image? Because yeah, how did
Yeah, I'm not very sure. I think that DALI is definitely there are some of these tools that are specific for visual and images. I know DALI is one of them. So OpenAI powers ChatGPT, and ChatGPT has like two branches. A lot of what we know is the kind of open, public, free version. Excuse me. But there is OpenAI also runs a version of ChatGPT that's by subscription. The subscription is not outrageous. It's something that less than $50 a month and is month to month. So, but both OpenAI, it's also it has a board of directors and it has a structure like so there is part of it that has operations that are non-profit and other operations are for profit, like a regular tech company. But then Microsoft has invested quite a lot in funding OpenAI. Um, Now there's a competitor of OpenAI that's called Hugging Face. Hugging Face, it's very involved with large language models. And I think that there is maybe a couple more that would be at that caliber of really like competing with OpenAI. So I believe that DALI is also powered by OpenAI. And
yeah. So I just did a little experiment. I went through Gemini and did I put this prompt in an image, state seal of North Carolina drawn by a fourth grader. And then I did like a Google search of the state seal of North Carolina and like the fourth grader, like the Gemini version is nothing at all like what the real state seal is, you know? So I would chalk that up to hallucination, you know? It's like it doesn't know. I don't know.
yeah, I don't know if mine is actually creating. I mean,
I put image colon before the
uh-huh.
prompt, uh,
Yeah.
just because I want
Um,
it to be like an image.
so mm.
Oh,
So mine, I've gotten a few rejections like that today. So okay, Coda is saying, hey, let's type this. This is an example. Coda works a lot with cloud computing and um, information science, information technology. So commands in terms to create a LAMP stack server. So Cora, what do you think? This should be kind of like that thing about translating between languages and also probably also I would imagine that it's easy to find this type of instructions posted in many public websites. So, but it's nicely outlined here with like the sequential steps and the commands. So SQL Server, PHP. Wow. What does this look okay, or is all it's pretty good? It's pretty okay, yeah. So um oh, there's a note here. Use code with caution. So if I just copy that code, I'm gonna paste it here in the chat window. It's not a lot of lines of code. It's just the code that was in that window, I guess, but I see. To modify the file, the configuration file. Yeah, so I'm gonna try to just for demo here, sharing the screen. Let me see the just give me 1 second. So this is Copilot, and ask me anything. So this, of course, this requires 365 a 365 account. So I'm gonna try this thing here, creating the North Carolina state seal. Hmm. So this, maybe I did the wrong thing here, but it's pulling like a lot of public information on this, and then even images found, but not quite what we asked of an imitation. This is another. So they have Copilot tab and Notebook tab. Yeah, I don't know what's happening with this Copilot. Okay, so it seems that the breakout rooms should finish in about 1 minute. Maybe I'm gonna stop sharing my screen. And and I should switch. Hold on just 1 second. Okay, so it seems that we're gonna have to adjust we only have 20 minutes left. And I still would like to say a few things when we come back about responsible AI, and then we'll move a little faster. Everybody should be heading back to the main room in 2 seconds. 1 second now.
My apologies, we got cut off mid-sentence.
Sorry, I
Yeah,
pulled.
we did too.
That's what they say. And just when I thought I was out, they pulled me back in. I pulled everybody back into the main
web we
room.
go.
Okay, so Andrew, let's do this. We're gonna adjust a little bit. I'm going to play the first video now, and then Andrew, when that finishes, you debrief about the first what is it, the first two slides, and then that's it. Then we switch over. Mike, you will maybe debrief us a little bit about that report. And then from there, we open to Q&A, and I'll show everybody how to download materials from GitHub, that kind of thing. Okay, so let me. My intention is to share a video with you, so I need to make sure that I'm sharing the sound. It seems the sound is on. Here we go.
Hi, I'm Jabril and welcome back to Crash Course AI. Algorithms are just math and code, but algorithms are created by people.
Can you hear the sound, the video?
Yes.
And use our data. So biases that exist in the real world are mimicked or even exaggerated by AI systems. This idea is called algorithmic bias. Bias isn't inherently a terrible thing. Our brains try and take shortcuts by finding patterns in data. So if you've only seen small tiny dogs, you might see a Great Dane and be like, whoa, that dog is unnatural. This doesn't become a problem unless we don't acknowledge exceptions to patterns, or unless we start treating certain groups of people unfairly. As a society, we have laws to prevent discrimination based on certain protected classes, like gender, race, or age, for things like employment or housing. So, it's important to be aware of the difference between bias, which we all have, and discrimination, which we can prevent. And knowing about algorithmic bias can help us steer clear of a future where AI is used in harmful, discriminatory ways. There are at least 5 types of algorithmic bias that we should pay attention to. First, training data can reflect hidden biases in society. For example, if an AI was trained on recent news articles or books, the word nurse is more likely to refer to a woman, while the word programmer is more likely to refer to a man. And you can see this happening with a Google image search. Nurse mostly shows women, while programmer mostly shows men. We can see how hidden biases in the data gets embedded in AI search engines. Of course, we know there are male nurses and female programmers and non-binary people doing both of these jobs. For example, an image search for Programmer 1960 shows a lot more women, but AI algorithms aren't very good at recognizing cultural biases that might change over time, and they could even be spread in hidden biases to more human brains. It's also tempting to think that if we don't collect or use training data that categorizes protected classes like race or gender, then our algorithms can't possibly discriminate. But protected classes may emerge as correlated features, which are features that aren't explicitly in data, but may be unintentionally correlated to a specific prediction. For example, because many places in the US are still extremely segregated, zip code can be strongly correlated to race. A record of purchases can be strongly correlated to gender, and a 2017 controversial paper showed that sexual orientation is strongly correlated with characteristics of a social media profile photo. Second, the training data may not have enough examples of each class, which can affect the accuracy of predictions. For example, many facial recognition AI algorithms are trained on data that includes way more examples of white people's faces than other races. One story that made the news a few years ago is a passport photo checker with an AI system to warn if the person in the photo had blinked. But the system had a lot of trouble with photos of people of Asian descent. Being asked to take a photo over and over again would be really frustrating if you're trying to renew your passport, which is already sort of a pain. Or, let's say you got a cool gig programming a drone for IBM, but it has trouble recognizing your darker skin tone. Can't relate.
Okay, Andrew, you can take it away.
All right, are you wanting me to start from the very first slide?
Sure.
Okay. All right, so that video you just watched discussed a little bit about responsible AI. And can you all see my screen? Dr. Gary, you give me a thumbs up if you can see it.
I see it.
Perfect. So responsible AI is pretty much guidelines set in place by it can either be an individual, group of people, or an organization. And its whole goal of responsible AI is or the guidelines are to reduce the amount of bias in an AI algorithm. In this case, bias being, it can be several things, but Main example would be like stereotyping based on group of people or traits that a group of people have, right? So, to illustrate this, here is a scenario in which is an institution of higher education is creating an admission systems that is powered by AI. So admissions is just determining who gets accepted into a school and who doesn't, right? And so when creating this AI algorithm, you're thinking about having this AI algorithm implementing the following policies, and you're to determine which one is the most fair. So the first policy is ignore gender, as you can read there. The second policy is to adjust for different groups. So, as it says, women might have had experience that led to different numbers than men or non binary people. Output reflects input, the third policy. So, if 30% of the people that apply to the school are women, 30% of accepted students should be women. And the fourth one is the prediction is correct. And this is pretty much the percent of admitted women who graduate is equal to the percent of admitted men and non-binary people who graduate. So I was going to ask, put you on the spot here, Dr. Garrett and Dr. Cintron, which policy do you think is the most fair out of these four?
I don't know, but
Yeah, that's a big social conversation right now. I'm not sure I
yeah,
got the answer to it.
but I'm gonna say this, and then Andrew, we don't need to go to the next slide, but um, class imbalance. So class meaning groups. In the context where you have some groups, categories, or classes, and statistically, this is what is called a categorical statistical variable. So in that context, it may be that if there is a class imbalance, is because in the samples, there is a class or a group where is overrepresented in the sample of data versus some of the other groups. And so one of the mitigations for enforcing responsible statistics or responsible AI is to mitigate for class imbalance. And there are some techniques that are about basically creating another sample where the samples between groups are a little more balanced, kind of more like almost an equal split or without preference, because the risk is if the input is this number of classes in the samples that have this imbalance, then the algorithm is going to prefer to have some preference for where there is more data or where there's, like is the algorithm is going to interpret that in some way that is not really meant to be. Okay, so I don't know if I said that something there about class imbalance, but yeah.
And with the algorithm too, it's hard to eliminate the bias completely in algorithm.
Yeah.
So as a person that's had experience creating different AI algorithms, your goal is to minimize the amount of bias. You want to minimize that as much as possible based on different metrics. Okay, so while some of these policies may stand out as, no, that's completely biased, we shouldn't use that, and some are kind of on the fence, right? Whenever you're creating these, you have to kind of play around and see which algorithm has the least amount of bias in it.
Can I add something to this, Andrew?
Yeah, Dr. Garrett.
In our breakout, we're looking at some scripts of a tutoring session. And on one of them, I constrained the GPT and told it to only do not tell the student the direct answer, right? So that's a constraint on the algorithm. So we're talking here, we want to constrain our algorithms to act in certain preferred ways, but it blew up on me. It created a toxic engagement with this child where it ended very badly. So my constraint I thought was good, but it produced a terrible outcome. And I think we have to bring that up with these problems too. You can try to tell the GPT to act in a certain way, and you can't foresee the consequences because it's too complicated. So there's
It's
got to
not
be
exactly like an autonomous car or something the
Mm-hmm.
automatic pilot is gonna fly itself off and land and right. It's not quite there. So, but I think Garrett and I like what Daryl's pointing out there also that Yeah, I would personally say lawmakers sometimes are disconnected. They live in some kind of other reality. And so, excuse me, but Gerald, maybe here we can switch and you can show on the screen the website with the report, and maybe we can have a little, I
Okay,
don't know, a little chat about that.
so I have to find it. Give me just a sec. What I'm looking at is something Ariel brought to the table here. There's work being done by people trying to figure out how to do this, how to use this in education. And this is a document which the URL will get to you. Is it from Cornell, a working group, try to figure out, well, what do we do with this artificial intelligence in teaching? So it's a long son of a gun, as you'd expect reports to be. And I just want to bring out a few points. So before I look into the text of this, let me show you what I think, what I want to bring out in these. So pardon my scrolling. I'm taking that you can all see my screen well. We good?
Yeah, yeah, we can.
All right, so there's the URL for this. Let me just pop that into the chat right quick. And oh, it's already there. Thank you. So their big thing is this AI is providing a lot of opportunities for teachers. I think that's pretty clear. And there's a lot of concerns. And in my chat room, people we were talking about, does it make teachers feel like they're not important, that they can just hand it off? How is cheating going to be handled and all that? And they make some recommendations, and the recommendations mainly are built around this. The dang stuff is here. It's already here. When students go out to get a job, they will likely confront some kind of AI engagement. So our job as educators is to get these people ready for the real world, and we got to do it. So they're suggesting that we get good at help kids get good at engaging and evaluating AI, not to simply tell them to don't use it. You got to learn it. So one thing they suggested was add AI to your learning outcomes. So in other words, you're trying to teach AI. You're trying to teach people it's in your lesson plans. How do you use it? And then teach children to be aware of these problems, these hallucinations, these toxic engagements, and the biases that are being foisted on them. So you got to teach them that. They got to be ready. And then you have to be very upfront in your own class with your expectations. So you can't just let it be vague. You have to spell out, how is this going to work in our class? So given that, I want to go back and look at that document right quick and see what their language looks like. So I'm looking through the executive summary more or less. So here's where they talk about the opportunities, and it's in the news. The proposed benefits, customized learning for everybody. It matches their needs. It gets rid of language barriers, and it's extremely good at understanding colloquial language. And it can be written in any language. And you can do, adaptive learning or learning that's, so all these things are very positive. Concerns, okay, it's inaccurate. And that's a big problem. This is one that I experienced firsthand. You can engage with this stuff and it makes you feel terrible, right? And that was because I constrained it in a weird way and it gave weird answers. The biases, as was mentioned, and then as a lot of people probably thinking, you can it'll start spitting out things that are copyrighted and you get people in trouble using prohibitive stuff. And you can circumvent what they politely call here the process of learning and assessment. In other words, they don't have to do their homework. The chat will, and they are not being tested. The chat is, so they can cheat. So these are some of the problems. Now, here are their recommendations, the ones I'd mentioned. You've got to rethink what it means to what you want your students to learn. You got to build it into your curriculum. I want you to learn about this stuff. You have to teach them about safety and ethics. You can't just assume they'll get it. So when is it safe to use? That's probably the one teachers don't think about. We think more about when are they going to be cheating and using it unethically. But you can get into an engagement that just is ruinous. So you gotta help people explicitly in your class, and then you've got to state your policies, right? You can't just say, we're going to use some AI and just be fair about it. So they recommend these 3 levels. And you got to think it through when you design your lessons and your assessments. You can say, no, do not use GAI on this when it interferes with the student's development. So you've got to figure it out. When do I want the people to pick up pencil and paper and do this stuff on their own? And when, and you got to tell your kids, don't use GAI for that. And then this part, when do you allow them to use it? But you got to tell the teachers that you used it. So if you're creating a PowerPoint and you want a picture of a certain kind and you ask the AI to create the picture, you need to put that in your footnotes. I used AI to do this, and that's a rule that you build into your class. You've got to tell me when you're using it if you're using it in a creative sense. And then the last thing is there are times when you want to encourage that they go out and use this stuff. You design lessons that ask them to go out and find GI or use the one that you're tailoring and so on. So every time you ask someone to do something now, you've got to consider these 3 possibilities and be very clear to the kids about what you want them to do.
Thank you so much, Garrett. I'm sorry to step in here and disrupt you, but this is a really good synthesis. We have officially 2 minutes left, and I wanted to redirect and make a couple of remarks here as we're approaching the end of the session. So first is that where you can go and download the slides we used today, download. So I'm gonna paste this URL into the chat window and make sure that everybody gets that. So this is a GitHub repo, and specifically there is one PDF that says curated GAI. When you visit each of those, just make sure here on the right side there is an icon with an arrow that says download raw file. That's probably the best thing for you to do. Download all the files. What Gerald was mentioning is a link here as report GAI for education. And there are a few more things there. And then the other slide decks we use today are also available for download. You can always use the README file out of here, and that will point you in the right direction. So the other thing I wanted to mention is if you join us in part 1, you already submitted a survey, an exit survey for the Tennessee STEM Innovation Network. If you have not done so, there are like 2 exit surveys. So when you're doing the Tennessee STEM Innovation Network, you'll find a couple of questions there. One is about what is the hub. So the STEM Innovation Hub is called Northeast STEM Innovation Hub Johnson City. And then the name of this training session is called Generative AI for K-12. That's one. If you did it for part 1, you don't need to do it again. So one time would suffice. And then we have an exit survey that's specific to part 2, where some of the information is information you had provided before, but there is couple of additional questions there. So it would be really useful if you could, do this exit service on your way out sometime today. But thank you again. I mean, I'm gonna stay here for a few more minutes. I want to thank everybody for attending. Yeah, it was really super great to have this opportunity and have this forum, and hopefully we can do more workshops like this in the future. So that's part of what I encourage you to fill out that second survey, the forms, the Microsoft forms. At the end, there's a question there about additional comments if there would be topics like cloud computing or more specific AI, machine learning, things like that. We could definitely do some planning, and then either summer or fall semester we can organize more workshops. This is a part of a series. It's called Innovative Educator Workshops. They are housed under the Center of Excellence for STEM Education at East Tennessee State University. So thank you, everybody.